This video is going to talk about Graham's Law. And what Graham's Law is going to do is it is going to focus on assumption 1B in kinetic molecular theory, where the gases have no attractive or repulsive forces between them. And what 1B allows us to do is it leads to the ability for gases to diffuse and what we call effuse, E-F-F-U-S-E. And the difference between diffusion and effusion is diffusion is the movement between materials. And effusion is gas escaping through an opening. It's a P. And the way that I can remember these is I remember E for effuse and E for escape or E for exit. And so let's talk about things that can affect effusion and diffusion. All right, so the rate of effusion so the rate of effusion is dependent on the size of the molecule. And if I think about sports teams, usually the quickest players on the teams are the smallest. So the rate of effusion works the same way with molecules. So the rate of effusion is proportional, and we use the Greek letter alpha. Oops. Oh. Here we go. Oh, what did I do? Here we go. All right. We use the Greek letter alpha for proportional to. It is proportional to 1 over the square root of the molar mass of the gas. And so what we can say is if we were going to compare helium versus, say, carbon dioxide, helium would effuse faster because it has a smaller molar mass. So the rate of effusion would be higher because this number is smaller, so this is going to give us a bigger number. So this is faster and this is slower. Okay? Now that's only helpful when we're comparing effusion rates. But when we actually are talking about diffusion, we're talking about movement between materials. So what we can say is for diffusion rates, is if we had the rate of A over the rate of B, that is going to equal the square root of the molar mass of B over the molar mass of A. Now be careful because we have rate of A over rate of B, but then we have molar mass of B over the molar mass of A. And it gets back to the fact that smaller things will diffuse faster than larger things. So we need to keep that in mind. All right? I will post some sample problems that you can work on after you've watched this video.